In this video, we're going to extend our knowledge of an exponential function and look specifically at what makes it get bigger and what makes it get smaller. So the equation that we used before said y equals a times b to the power of some x. And it's still in that same format. It's just that we're going to look specifically at where this b comes from. And it comes from the fact that when we are making something bigger and smaller, we want to actually start with one whole value. And then we're going to increase or decrease it by some percentage. And that's all this is. That's all that b represents, is 1 plus or minus some value. And these are actually going to be given as percents. So we need to make sure that we convert them to decimals. But a is still our initial value. Y is our total value. R is going to be our growth or decay rate. And our rate is going to be given as a percentage, and we must convert it to a decimal. And that's why this is a 1, is because we're always starting with 100% of what we currently have, and then we're making it bigger or smaller by another percentage. And then if we turn 100% into a number, we move that decimal 2 places, and we get 1.0 or just 1. So that's where that 1 comes from. So if we look here in our first example, we do see this word exponential, and that's how we know our answer is going to go in this form here. Because we continue reading and see that we are given a percentage, that means when we look at percentages, we're really going to take b and we're going to separate it into 1 plus or minus that r value. And so again, these formulas are the same thing. It's just in the blue formula, we've taken b and we've separated it out so that we can specifically see, in this case, this growth rate. Okay, so it says our original value is 1,400. This is going to be a because it's our initial value. And the value is increasing by 9%. This is going to be r because that's our growth rate. So if we fill this into our formula, I'm going to go ahead and I'm going to use function notation. So I'm going to call this f of t. It's always going to be whatever our initial value is. So 1,400 times 1. Remember, that represents, we're going to use 100% of this amount we started with. And then in this case, we're going to increase that by 9%. And 9% needs to be written as a decimal. So if I take a percentage and I want to write it as a decimal, my decimal is here unless I see somewhere else, and I'm going to move that 2 places to the left. So I now have 0.09. And that's going to be to the power of t. So this is the equation that's going to give me the final value of the painting after any number of years. And so it says then, so after we've written that equation, we need to find the value of the painting specifically after 25 years. And I'm going to use function notation here. So I'm going to say f of 25, and that just means I'm going to take the equation we called f, and I'm plugging in 25 for t, equals 1,400, and I'm going to go ahead and combine my terms here, so 1.09 to the 25th power. And remember, with function notation, all we do is plug this side into our calculator, and we're going to get $12,072. And I'm going to round this to the hundredths because this is referring to money. And so I'm going to label this as f of 25. So to answer this question, we would say the value of the painting is $12,072.31 after 25 years. Okay. So our next example is very similar, except this time it's going to be exponential decay. Again, they're giving me my decay rate. So instead of writing my formula as a times b to the power of x, I'm going to use the more specific formula where we take b and we split it up into 1 plus or minus r to the t power. So again, this is just a different way to write b. And when we plug our values in, Again, I'm going to use function notation. I'll call this one g of t. Our initial value in this problem says that in the year 2000, so this is my beginning year, we have 1,300 people. So 1,300 is my initial population. In this problem, it is decaying. So I'm going to start with all of my population, or 100% of my population, but I'm going to decay by 1%. And instead of using 1%, remember we're going to write that as a decimal. So we're really going to use 0.01. And that's going to be to the power of t. So this is like 100% minus 1%. And that's where that number comes from. And so this is the formula that will give the population of the town after any amount of years. And the question specifically wants the population now in 2008. So be careful, we're not going to plug in 2008 here, or that would calculate the population after 2008 years. And all we want is to know the population after 8 years. So we just look at how much time has gone by. So we're going to plug in 8. And all we do here in our calculator is type in everything on the right-hand side. And here we do get a decimal. We get 1,199.568. But in this case, we're talking about the number of people. Obviously, we can't have part of a person. So this is going to go up to 200. So we would say there would be 1,200 people in the town in 2008. Finally, our last example is kind of worded in a little bit different way. So here they've given us the formula. And yes, this formula is an exponential function because my exponent is a variable. So technically, this is like y equals a times b to the power of x. The question says, what was the initial population? So my initial population is always going to be this out here. So I would say initially, or when we began, there were 3,215 bees. The next part of the question says, does this represent exponential growth or decay? And so remember, the way we get B is really by starting with 100% and adding or subtracting some percentage. So we can tell if it's growth or decay by if it started with 1 and went up, or if it started with 1 and went down. And if we look at this value, because this is greater than 1, we know that originally here in the parentheses, we had to have had 1 plus some rate, or in this case specifically 1 plus 0.012. So since it went up, this represents exponential growth. So we could just say this represents exponential growth. And our reasoning is just that our b value is greater than 1. So when we start with 100%, we had to add to make the number greater than 1.